Welcome to all. See, from today onwards, that is from this class onwards, I am starting analysis of doubly reinforced sections by limit state method. Now, one most important concept. As the class goes on, I will tell more about it. You first make a note. See, don't see the board now. First make a note. In case of analysis or later design of doubly reinforced sections by limit state method, we need or we require or we have to find a term called FSC. You write that way, FSC. F means stressy. FST, you can tell stress in steel in tension. In limit state method, it is 0.87 Fy. Okay. FSC is, F stands for stress. Stress in steel, very important now. C for compression. So generally you can call as stress in steel in compression. That is for compression reinforcement. Remember, this is to be used for ASC, because as we go to doubly reinforced section, apart from AST on tension side, compression side, ASC also will come. But now, important, what is the meaning of FSC? In IS code, they use the word, see IS code, I tell page number, I won't tell, IS code, page number 56. It is given. FSC is, I will read now, this class slowly I will take. FSC is design stress in compression reinforcement corresponding to a strain of 0.0035 into XUmax minus D dash divided by XUmax. Now, this is where so many people make mistake. Not so many, majority people. I will tell you one more thing. There is lot of confusion and mistakes committed everywhere regarding this FSC. And also, for that matter, regarding analysis of doubly reinforced section. So many places, they perform the analysis in the wrong way, which is not correct. See, I am not telling, I am not the only person knowing it. There may be so many people, no doubt. But I told majority, see, mistake is always a mistake. High time, they start correcting it. Now, what mistake they make and how to correct it, that all will come exclusively in a series of classes by me. I am preparing the series of classes. Common mistakes committed everywhere. Majority. Again, every time I will tell, I am not the only one knowing. People are there who know it. But people who do not know basic concept, percentage wise, I don't want to tell, leave it now. So many, I think around more than 99%. People does not have the proper concept. So even this FSC calculation, people make mistake. And also analysis of doubly reinforced section, furthermore mistakes. I will tell one by one in this class, but exclusively mistake oriented. My purpose is not to, I told, insult them or degrade them. My purpose is to tell them the truth or correct concept so that they will correct it. Okay, now, FSC means what? See, I am telling you, depends whether it is an analysis problem or design problem. IS code has given for design purpose. See, they told very clearly, design stress in compression steel. So therefore, the term FSC, when you go for design, it is called design stress in steel in compression in case of design, correct? That is as given in IS code. As given in IS code. But remember, in case of analysis problem, see, I am telling class means I am explaining something here. You should write it. In case of analysis problem, FSC is very delicate part. It is stress to be considered. Their term called FSC into ASC will come. There, ASC, you know it. What FSC you have to consider for analysis. So what I will do is, if it is an analysis problem, you call it as stress to be considered in steel in compression for given cross section. Whenever given cross section is there, it is analysis. So for analysis, but for design, okay, it is called design stress. One part I clarified here. Now, one by one I will tell you the way I explain. You should make fair copy in that order. Don't write this way. I will maintain the order here. After writing all this, FSC is to be calculated based on epsilon SC, not Young's modulus here. See, epsilon strain, epsilon SC. That is strain in steel in compression. Now, how to find epsilon SC? Expression is epsilon SC is 0.0035 into XU minus D dash by XU. This I explained thoroughly in the batch. For you also, in the next coming part, I will tell how it came. Okay, leave it now. Right now, I will tell sometimes. Right now, believe me, some student will tell, yes sir, we will believe because, see, matching with the IS code. I will tell not matching. Now, note, IS code, page number 56, I am telling in the class now. They are given expression for epsilon SC. They are not told epsilon SC, they told strain in steel in compression equal to 0.0035 into XU max minus D dash by XU max. See, red color, XU max. No. Do not use this for analysis because it is only for design. This is where so many people make mistake. They will tell IS code given. You should see IS code correctly. Where they given it? They given that expression when you have to design the cross section or when AS is to be calculated. They told MU minus MU limit equal to FSC into AS in D minus D dash. They told compression reinforcement is to be calculated, means design part. People don't understand that much. They take blindly from IS code. So remember, make a note. Even though IS code, in the IS code, this formula is given, expression is given, they told XU max that is only for design purpose. You should write only for design purpose. So analysis purpose, always do not take XU max, take XU. Little later in T-beam also I will tell. IS code has given equation for MU, for T-beam, where they used XU max. They are given only limiting value. Then they told somewhere else, if your XU is less than XU max, they told consider XU as it is. See, they told it. If the XU comes less than XU max, do not take XU max. They told replace that XU max by as it is XU. They are given there. People don't see that much now. So, in the equation, always consider XU only. Do not write XU max. No, consider XU only. Later, if XU equal to XU max, when either for over reinforced section, you can write here, either for over reinforced section or in case of design problem, okay, no problem, put XU equal to XU max, you get back this equation only. So, firmly remember, when you use the expression for epsilon SC given in IS code, do not consider that max. Later, if XU is equal to XU max, okay, substitute, it will come same. So, therefore, be careful, do not use this one. Use the basic equation, one concept. Next, come to this side. No, come this side now. This is over now. I told, no, come this side. For Fe415 steel and Fe500 steel, in SP16, page number 13, there is a table called F. So many people are using it. FSC values are directly given based on D dash by D value. See, we require FSC. They are directly given the table. You see the IS code. Not IS code, SP16, page 13, table F. They are given a table where for Fe415 steel and Fe500 steel, they are given directly FSC values given based on D dash by D. No, No. This also you cannot use. This also cannot be used for analysis purpose. This is also only for design. People use that for analysis. They will tell, SP16 given. No. I will explain it later, not here now. In that extra class, I told I am conducting some classes where it is actually mistake correcting classes. Someone will tell, oh, you are the one who are knowing everything. Yes, I know so many things. I will use it. When you have knowledge and when people are making mistake, if I correct, my purpose is good purpose, not bad purpose. Okay. So, therefore, do not use this also. But in same SP16, page 6, table A is given. But that is given only for FE415 and FE500. This later in the class I will tell. This table can be used. Yes, this can be used. Yes, can be used. Can be used for analysis. Anything you can use for analysis, you can analysis and also design. So, first to make all these notes, what I told, repeatedly go through 3-4 times and make a note. Now I will change over to calculation of that FSC, how to find that FSC for mild steel and torch steel as per IS code. As usual, I rub the board. Continue. Now, procedure to find FSC for both analysis and design. Both. Okay. FSC important. FSC is to be calculated based on epsilon SC. What is FSC? What is epsilon SC? Already told. So, it is already told. Therefore, write it if you want. Now, first find epsilon SC. How to find epsilon SC means already told. I will write here. Actually, I should not write. Already told. By the expression. Actually, already just now told. By the expression epsilon SC equal to 0.0035 into XU. Don't write XU max. XU minus D dash divided by XU. Okay. Already told. Okay. Now, very, very important. See, make a note here. See, very, very important now. This, you make a note here. This epsilon SC now onwards, we will write, to understand correctly, epsilon SC calculated. Very important. Calculated based on this equation. First try this one. See, in future, see, otherwise confusion comes because see, you can see one more epsilon SC later. So you refer at calculated value or actual value over. Now further procedure. How to find FSC for epsilon SC calculated. Refer IS code page 70. My IS code is very dirty. Okay, IS code page 70. Now something I will tell here. Right here. I am going to dictate now. You should write it. Page 70 at present. See, present printing. Suppose they reprint the IS code or new edition, page number may change. It is possible one figure can come in that page, one can come in this page. They can interchange, but words they will not interchange. So, I told at present. At present, I told printed. Somewhere I told here. At present printed. Okay. That page, upper side and lower side, two figures are given. 23A upper side, 23B lower side. Now, you require concept for mild steel and torch steel. Remember, at present, mild steel is not at all used. It has completely outdated. I wrote here. I am explaining mild steel, not at all used nowadays. Here I am explaining just for information purpose. Or Suppose you are writing examination. There they can give mild steel. So students, it is very useful. See, because sometimes even a student can go through this one. He will understand everything. Then, of course, some students, they may not go through all this one. Whatever given in the wrong procedure, they will follow it. Those who are interested, serious people, they will go through. So student requirement are given mild steel. Other is torch steel. Now you should remember. So in the order of explanation by me in this class is first for mild steel, then for torch steel. Why? First unwanted. Unwanted means what? Practically unwanted, but theoretically required. Second is for torch steel, but here it is interchange. First they given for torch steel, then mild steel. Now remember, how to remember it? See, 23A they told, where I given? They told somewhere. 23A, see I made dark AY important. This is important. This is not required. Practically not required. 23A, they told, is printed upper side at present. And they told it is for cold worked deformed bars, CTD bars. Some people call HYST bar, that is for torch steel. It is not clearly mentioned. Twisted bar, torch steel, remember. FP415, right here. FP415 or FP500 or tomorrow, who knows, FP550 may come. If IS code is not giving any modification, same curve valid. If they want some correction, they will give it. Then, that is upper side. Lower side, it is printed as for, see, this is for lower side, 23B. Steel with the definite yield point. That is mild steel. See, torch steel, you can see here some curvature, all you can see there. To before Fy, you can see a curvature. Means what? The proportionality is not valid up to Fy. Little earlier only, stress strain linearity lost. But mild steel not that way, straight line they given full. So upper side is for torch steel, figure 23A, 23B lower side is for mild steel. Sometime in the class students I will tell how to note means, see the IS code, see. I will ask them, see among the two graphs, which is simple and plain? Sir, bottom sir. Why? Sir, just like this sir. Yes, that is for plain bars. See, bottom, okay. Then I will ask you, which is actually twisted, turned? Sir, upper side sir. Why? See, you can see so many things there sir. Turnings are all there. Twisting is there. You can remember that way also. Crude method. See by words there. Okay. So remember, upper side is for tor, lower is for mild. Okay, now first I will consider mild steel first, lower one. See. Now, for see, too much of concept I can't give. In the regular batch, I told so many concepts for them. See, this is, they told stress and strain. They told strain here and stress here. When you are finding FSC based on epsilon SC, strain means epsilon SC, stress means FSC. That's all. Okay. Because why? Our stress is FSC, our strain is epsilon SC. Now, see, there you should make what all I am telling now, you should write now. Something I am dictating now. Two graph is given. One of them is, see here correctly what I am, you tell here, OAB, I will tell A dash B dash. Okay. One of them is OA dash B dash. That is corresponding to Fy. No. Other one is OAB. That is for Fy by 1.15. IS code told in limit state method, design stress in steel is not to exceed Fy by 1.15 or you take 0.87 Fy if you remember. Therefore remember, you should not use this curve. You have to always use Fy by 1.15. See, always refer the graph corresponding to Fy by 1.15. So remember, this is required. Use this or refer this. Okay. Refer this. Refer this. Now, therefore, refer only O, A, B, not O, A dash, B dash. No, don't use it. Use, see, I made dark here. This is to be used. The actually straight line only, I made dark to highlight it. Just line. Okay, now, what to do is, first to find this value, this strain. Okay. This strain, up to this point you can see straight line here. You should write everything what I am telling. So you can see a linear variation here. So this is the end point, epsilon SC PL. Sometimes earlier I used to write elastic limit, but actually elastic limit and proportionality limit are not exactly same. So use the correct word. See, when it's a straight line, it means what? Proportional. See, when this is a straight line, it means what? Stress is proportional to strain, linear variation. Therefore, you do one thing, this point you take strain, and so that is, you take this strain as epsilon SCPL. Sorry, epsilon SCPL, that is epsilon SC at proportionality limit, or simply in future to save time. Every class I cannot write epsilon SC at a proportionality limit. No, I will put PL. Not public litigation, not plastic. Proportion, in future I will tell epsilon SC PL. Okay. How to calculate? Epsilon SC, see now, PL, see, there is one epsilon SC calculated. See, this is epsilon SC calculated. Which one? This is your epsilon SC calculated. That is PL equal to, see, I'll write this way here. You have to use your mathematical concept. Actually, in the class I explained for them, for you procedure, it is directly Fy by 1.15 into ES. Remember. So whatever is this value, divide by ES. Why? You should know it. See, stress is proportional to strain, or stress equal to strain into Young's modulus, or strain equal to stress divided by Young's modulus. Here stress is Fy by 1.15 by ES. Okay, sufficient for you, because I am not taking a full-fledged course for you. I am only giving information. What I am telling is more than required, because my commitment actually is what? Simply give some procedure. Okay. So this is epsilon SCPL. Now what to do? Okay, I will rub the board and write here what to do now. Or see, this equation, where is it? I wrote somewhere. How it came, I will explain when I go to analysis problem, not now. This I will explain when I take up the first numericals, not right now. Because why? At that time, anyway I explain. Now, further steps, you should write correctly. Now compare epsilon S, I am explaining for mild steel, remember? Epsilon SC calculated with epsilon SCPL. You already know epsilon SC calculated. Just now you got epsilon SCPL, compare. Now see, if epsilon SC calculated is less than epsilon SCPL, means your point is somewhere here, anywhere here. See, here, 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 here. Then directly FSC equal to strain in concrete steel epsilon SC multiplied by Young's modulus. Actually common sense. But and case 2, suppose your epsilon SC calculated is more than, if the point comes somewhere here, you can see here now, see, once you cross this point, wherever you are, it is a constant value. Up to here, stress proportional to strain. When stress proportional to strain, stress equal to strain into Young's modulus. That's all. Further I can't tell, because very simple understanding required here. Or you take procedure from me, what to do. So, but not in the regular class. There I confirm that it is clear for students. So remember now, for mild steel, compare epsilon SC calculated with epsilon SC PL. If the calculated value is lesser or equal to this limit, then see, you can make out here, stress is lesser. You can make out here, see, stress is lesser. Fs equal to whatever epsilon SC you calculated multiplied by E of steel. Whereas case 2, if the strain is more than what, a proportionality limit, then Fs equal to Fy by 1.15. Okay. This will complete mild steel over, and Once I finish the procedure, before I go to WA info section, I will go for numerical example. All the cases, I will explain this one with the numerical values. It will be more clear at that time. But I will tell condition for you little later for that one. Not that condition of 100 request. You should study the procedure thoroughly and correctly understand, then only start numerical. Not directly come to a class and tell he is telling something, this one, that one, not clear. Leave the class. Not for you. For those who are not serious. Okay. Now, the most important, almost 100%. See, usually at present, mile steel is not given. Therefore, very, very important. I will not repeat. Once I explain everything here, and once I explain the numerical part with examples, and then I will start WA info section. At that time, I will tell, go back to first 2 classes, study thoroughly, come back, then only start studying. Do not ask me, sir, how this came, you are not explained like that. Yes, I am that way only. Okay, now the most important, that is torque steel. Note, IS code figure 23A. I told repeatedly, upper side. Remember, once I should not write. At present edition, at present upper side. Or where you can see the twisting all. Okay, now, this is a graph given there. See, you see that? You open your IS code, you see the graph. You can see some plenty of dotted lines here. Do not see it. See, what all I am telling in the class, write it. You can see plenty of dotted lines here. Do not see what are those lines at present for you not required. I know the meaning, but this is not the time to explain that one all. That is for higher knowledge. Leave it now. So, see only stress strain curve. Okay, now, this way strain, this way stress I told. Strain means epsilon SC, stress means FSC. Okay, now, to find FSC corresponding to epsilon SC calculated. How calculated? I should not tell. By the equation, again I am wasting time. Epsilon is equal to 0.0035 into XU minus D dash. Already told XU. Okay. Now you know calculated. See. First find epsilon SC PL. Epsilon SC PL means same statement. I want to tell once again. Epsilon, right here, epsilon SC strain in steel compression at proportionality limit. Remember, one important. This is Fy curve. This is Fy by 1.15 curve. So, you should not use this one. IS code told use this curve. So, if you use that curve, see this point, if you come down here, this is epsilon SCPL. See, this is a straight line. End of straight line for this curve. Don't see this one. That value equal to 0.80 Fy. Remember, I won't tell once again. Divide by 1.15 ES. This is a formula for, now one big note to make here. For mild steel, the formula is, see, for mild steel, formula is Fy, just now I told, Fy by 1.15 ES. Somebody will ask, sir, why 0.8? I am telling you, take it. There is no time to go that much deep because this is actually, you are down, 0.8 comes here. You should come down by 1.15. No. That I explain in the batches only, not here. First of all, I am telling more than what I am supposed to tell. So, you make a note here. If it is mild steel, 0.8 is not there. For torque steel, see, this 0.8 will come. Remember that one. Over. Now, compare epsilon SC calculated with epsilon SC. That is same as mild steel. Case 1, epsilon SC calculated is less than epsilon SC PL. Means you are somewhere here. Then, same as mild steel. Directly, FSC equal to epsilon SC calculated into ES. You write here. Same as last time for mild steel. But Case 2, you should be careful. Case 2, epsilon SC calculated is more than epsilon SCPL, means you are somewhere here. See, here. Then, one note, see, this case of epsilon SC calculated coming less than epsilon SCPL is very, very rare case. It never comes. So, when epsilon SC calculated is more than epsilon SCPL, it is usually for torch steel, we always get this case. Therefore, very, very, very important. So, your complete subject point of view, mild steel, first of all, not required. This will never come. Which one? Epsilon SC calculated less than will never come. It never came in my class so far. So, actually some will tell, then tell, why don't tell only one concept? No, systematic. So, this class really starts from here. Okay. Then get the FSC using figure 23A. How doubt will come? I will explain. You write everything neatly now. See, I am explaining now. You should write. You write neatly everything. See, I will tell something now. During numericals, once again I will tell. But when I go to problems, I will not tell. Wherever you are, see, wherever you are, it may be here. Surely one thing sure, you are this side. See, you are this side. That is guaranteed. Okay, now, you should not use Fy curve. You should use Fy by 1.15. But unfortunately, right here, you should write unfortunately, when IS code here gave the stress value, you can see there 0.8 Fy. Next you can see there, see, you see right here 0.8 Fy, 0.85 Fy, 0.9 Fy, 0.95 Fy, 0.97 Fy and Fy. Unfortunately, IS code has given all the values corresponding to Fy curve. Corresponding to Fy curve. Actually, this curve cannot be used. You have to use this curve. What to do? But for this curve, see, suppose you are here. When you go here, you cannot get it. So what to do is, I will tell now, I will rub and write now what to do. Okay, here. Okay, this is okay. I will tell what to do now. See, in a box I will tell. Okay, what to do. Use, we have to consider curve corresponding to Fy by 1.15. But unfortunately, in IS code, stress values are given. I am writing roughly. I am writing because I am dictating. Are given corresponding to Fy curve. You can write here Fy curve. Therefore, nothing to worry. Right here. So, but therefore, nothing to worry. Use Fy curve. Use this curve. Okay. From here, go to this curve. Maybe, see, come to this curve. Use Fy curve. Get the stress. But never forget to divide it by, divide what? Divide the stress obtained by 1.15. Okay. Now, actually you have to use this curve. But IS code has given for that one. No problem. Use this curve. Okay, wrong curve, no problem. See, use that curve. Get the stress. When you write the answer, you write, we get whatever you got here. How to get? I will tell you in next class. Numericals. Whatever you get after writing never forget to, see, never forget to divide by 1.15. This much information sufficient. Okay, now little more information is there, I will tell. Now, some extra information for tor steel. When case 1 epsilon SC calculated less than epsilon SC PL, very happy case. Why? Directly FSC equal to epsilon SC into ES, already over. But for case 2, that is tor steel, our most popular, when it is more than epsilon SC PL, we have to slightly struggle using IS code. Why? Values are so small, we will have difficulty there. So also there is every chance of some error, or what we get is somewhat approximate. That graph, exactly you cannot get it. Some struggling is there. Wait for some time. Next class it will come. Now, good news, but note, for this case of tor steel, when your strain goes above PL, you can remember it here. Instead of struggling, one alternate approach is there, if available. In SP16, table A, page number 6, FSC values are very easy. You can get FSC very easily using that table where they are given FSC values based on strain. So I will explain in the next class, where table starts for epsilon SC equal to equal. See, less than that table is not given because they know it. If the strain is less than the PL, direct answer. So their table starts from PL only. So use it. So, but note, SP16 table A can be used only for FE415 and FE500. Suppose tomorrow somewhere FE550 comes, we cannot use the table, you have to go for IS code only. Okay, now, also never and never use the table F. Based on table F is based on D dash by D. It is wrong. That is valid only for design. But this table valid for both. It can be used for both analysis and design. Okay. I made everything clear. It will be 100% clear when I take up next class. That is numerical example. I will take 4 cases. Mild steel 2 cases and tor steel 2 cases. Okay. Thank you. We will meet next class.